In the name of Allah, the Compassionate and the Merciful. Hello guys, in this video I'm gonna show you how can we pushover analysis of 2D steel structure as you see by hinge-by-hinge concept. This hinge-by-hinge concept is very simple method for learning pushover analysis and modeling and as I show you later, I modeled it in Excel step-by-step procedure, and stage is available and shown. So let's start it. As you see, we have the 2D steel structure as you see with 3 elements and different axial and flexural rigidity. The global degree of freedom of this structure is 12 degree of freedom, but just 6 degree of freedom of this structure is realistic. So actually, for solving our equations, we have at the first 6 degree of freedom. But step by step, when we have an incremental force in degree of freedom 7 in node 2, plastic hinge occurs in different nodes of this structure. So the degree of freedom is increased from 6 degree of freedom. So let's see our modeling in Excel. So as you see, I wrote the Excel file like this, and I tried to show a step-by-step procedure of this analysis and solving equation with Excel solver. You can use it with different methods such as inverse matrix or any conditions you like. So as you see, I used the section properties BF, TF, TW, H1, HW1, HW2, and HW2. Actually, in our structures, in any section of our structures, we have a different height of web, as you see. So, and height of column in column 1, height of column in column 2, I mean this one and this one, H1 and H2, I mean this. So length of beam, modulus of elasticity of the beam, yield stress, and allowable stress, and so on, and plastic moments of the beam, plastic moments of the column number 1 and 2 is calculated. So the coordinate in every stage or every step, I better say, local and global matrix are calculated, and then the analysis is finished, and then as you see, and in each node moment of this element at the bottom and top of the element is imported and then checked to the plastic moment, as you see. And if the alpha, as you see, is the less one, so we guess that the next plastic hinge occurs in this node. For example, in the member 3 node 4, it has the minimum alpha, so the next plastic hinge occurs in this node. So as you see, the plastic hinge is accurate, and in degree of freedom number 6. So in next step, or better say stage, we must increase our degree of freedom, and as you see, the local and global matrix is calculated and all the local matrix is assembled. So we have in here all global matrix and incremental load in degree of freedom number 7. So degree of freedom number 6 is shown because it is increased. At the first we have 6 degree of freedom, but now we have 7 degree of freedom. So as you see in here, we have 7 degree of freedom, and all the and displacement is calculated, and all member actual shear and moment of this element is calculated. And let's see, if we check the moment of this element with a plastic moment which I described before. So as you see that the minimum alpha is occurred in member 2 joint 3. So as you see, I mean this one. So node 3 and node joint 3 at the first one. So in member 2, so it occurs in this one. So degree of freedom number 13 is applied to this structure. So now in next stage we have 8 degree of freedom, and the formation of these structures, as you see, is deformed like this. So in stage 3 actually we have 8 degree of freedom. So we update all data, but the global and the local matrix is the same, but now we have 8 degree of freedom. So in here, as you see, we have 8 degree of freedom. In this stage D3 is we used for 8 degree of freedom, and then we inverse this matrix, this global matrix, with applying load in degree of freedom number 7. So the displacement is imported, and then all displacement goes to local matrix for calculating the members force, such as actual force, shear force, or moment force of each element, and then checking for moment if it is executed from plastic moment. So as you see in joint 1 in member 1, alpha is minimum. So the next plastic hinge occurs in joint 1. So let's see in here in joint 1 in degree of freedom number 3, next plastic hinge is occurred. So the formation of this plastic hinge is shown, but I better say this plastic hinge must be here. It is not correct. It is shown in here. So, and last in the last stage, I'd better say all local and global matrix is imported and then assembled in here, and actually in this situation degree of freedom is increased in here. So in this situation we have 9 degrees of freedom, and we inverse and solve this equation, and all displacement rotations are calculated, and as I described before, we imported in our displacement here and for calculating the members force. And as you see, for checking our moment, it shows that in member 2 joint 2 we have the minimum alpha, so the next plastic hinge occurs in that case. Let's see, in that case, so the next plastic hinge is occurred in this stage, and the formation shapes goes to this space. So the next stage is the collapse of the structure, so we are not going to calculate the next stage. And if we import a step by step of this stage base shear and displacement for drawing the pushover and displacement analysis, you see that we have this graph. I used Excel solver for solving my equations, and actually I want to minimize the weight of structures, and you can use your methods or even your conditions for solving these linear equations. And as you see in this Excel file, it's very simple for learning and checking the pushover analysis step-by-step methods, and it is very user-friendly to learning non-linearity of structural engineering, such as modeling of any kind of analysis, behavior of plastic hinge, or even any models you like. So guys, I'd like to know your opinions about my modeling and my Excel modeling, and any examples you'd like. So thanks a lot. Bye.